Okay, section B, as you can see, it is very straightforward. The only difficult question is the fluff up bird. So let us look at section C. Remember, you have to answer both the question. You do not have a choice yet. Okay, so again, you can see that you're given a temperature curve, and then you're given a setup. Now, if you look at the setup, as long as you see surface, it is a signal to you that you have to talk about radiation, because radiation is the only heat transfer that is affected by the surface condition. For example, color, the texture, so on and so forth. Then it gives you the temperature. As you can see here, it actually cools down pretty fast at the beginning, and then after that it just go almost constant here. So state the temperature represented by T in figure 1b. So if you look at this is the T that you need to identify, and just by looking at the graph you do not know how to do it. So read the passage. So here it says that this container initially is containing boiling water is allowed to rest on a bench in the lab, and the room temperature of the lab is 28 degrees C. So it means that this boiling water is going to cool all the way down to 28 degrees C. Just imagine you go to a kopitiam, the kopitiam room temperature is 28 degrees C. You go to the kopitiam water uncle, and then you go and order hot Milo. The hot Milo can be 80 degrees C. If you leave it in the kopitiam for a long time, it will cool down to what temperature? It's room temperature, right? Will it become an ice Milo? No, right? Because the room temperature is the lowest it can get. It reaches what we call thermal equilibrium. Okay, thermal equilibrium means that it is a science vocabulary that describes two objects are of the same temperature. So in this case, your boiling water and your room temperature becomes the same temperature, meaning that the room temperature will be 28 degrees C and your boiling water, okay, will become 28 degrees C as well. So therefore, the answer for the value of T is the room temperature, which is 28 degrees C. Okay? State the process by which container A cool down. So if you look at this, okay, how will it cool down? Now, this straw mat, okay, straw mat actually traps quite an amount of air. And whenever something can trap air, air being a bad conductor, it tells you that conduction is going to occur very slowly. So the amount of heat lost through conduction will be really bad. So conduction, you know that it is playing a minor role. The next thing you need to examine is convection. Now convection requires the water vapor to leave. Okay, because convection will heat up the air around it, then the air around it will rise. As it rises, it carries away with it heat. So since this thing is being covered by a plastic cover, you know that convection or evaporation will not be the main role also. Okay, because the cover simply prevents the hot water vapor from leaving the system. So in a way, it is slowing convection. So you are left with radiation. So radiation is affected by your surface, and if you have a dull surface, it means that it is a good absorber and a good emitter. Both are good. That means it can absorb heat very quickly and it can also lose heat very quickly. But look at the context. The context here is that the boiling water is at 100 degrees C. The room temperature is only 28 degrees C. So will this container A absorb or emit? Okay, you think about it while I write down this thing. So remember, dull surface, it can absorb the heat quickly. It can also lose heat quickly. But this is, okay, the characteristic of dull surface. You need to look at the context. The context is the water is hot, surrounding is cold. So will this container A be absorbing heat or will it be losing heat? Okay, so heat will always travel from high temperature to low temperature, right? So therefore, this container is going to lose heat. So when you are describing or elaborating on the dull surface, do not mention absorb heat because it is not suitable for this context. Okay, so now that you have the concept, let us put it into words. So just now we already talked about it. Conduction and convection plays a minor role. Okay, so talk about the main one first. So heat is going to be lost through radiation, and the dull surface is a good radiation emitter. Now this is the same as saying that the down surface will lose heat quickly. Remember to specify Y, radiation. So if in exam you forget about emitter, you do not know what it is, you can just say that the down surface will lose heat quickly, Y, radiation. So this VIA means that it's by radiation. Okay, it's just a more fanciful way of saying that. So you can replace good radiation emitter by lose heat quickly Y, radiation. But of course, if you can remember this, it will be well done. Now, because this is a 3-mark question, so after you mention the main method of losing heat, you need to talk about conduction and convection also. That's how you get the 3-mark. So I'm going to talk about conduction. So heat is also going to be lost through conduction. Okay, when the heat is conducted through the metal wall and to the layer of air around the container. So what happens is that this is the metal thing. The heat is going to be conducted through the metal part and to the air surrounding it. Okay, yes, it is going to be a slow process, but it does happen. So since it is a 3-mark, we will talk about it. So after you talk about conduction, the last mark will be on convection. So therefore, once this layer of air receives the heat through conduction, the air is going to get warm up, right? And when the air gets warm up, because it is mobile, the air will become expanded, and then after that the density will decrease and then it will rise. So the warm air near the container will rise, and then convection will cause the cooler air to replace the rising warm air. So what happens is that the air around this will rise, so this guy will rise, and the air around it, which is cooler, will come in here to replace this. So that is convection occurring here. Now I know that at the beginning I said that the plastic cover is preventing the convection happen here. Now what I mean here is that it's from the hot water vapor cannot escape. So convection cannot happen by the hot water vapor, but the air around the container is mobile. Nothing is stopping this air from moving. So this air can still set up a convection. Okay, and this convection is going to carry away with it heat from the container. Okay, that's what I'm saying here. So this is your full thing. You can pause and then you can take a look. Okay, pause, finish, next question. Beauty of YouTube. Okay, then after that you are told to sketch another graph on figure 1b and show how the temperature will fall if the container is not covered with a cap. Okay, then label this graph as C. So I'm going to go back to 1b. Okay, this is the figure 1b. I'm supposed to sketch another line. Now, this line is going to describe the how the temperature cools if this cover is removed. So without the cover, the hot water vapor can escape. And when the hot water vapor escape, it's going to carry away with it heat energy. So therefore, without the cover, will it cool faster? Yes, right. So it will cool faster, meaning that at the beginning, it's very hot. After 1 second, this is with the cover. This point represents the temperature with the cover. So without the cover, this temperature is going to drop. Right? So this is my new point. So if this is my old point, my new point should be here. This is my old point, my new point should be here. This is my old point, my new point should be here. But once it reaches the room temperature, it's going to stay there. Right? Your hot Milo will only cool down to your room temperature, right? It cannot become ice Milo, right? So same thing, once you agar-agar, have all these points, just plot it. As long as your line is below the line given by the question, you get the full mark. Now, think. Is this the full answer? I just want you to think. Look through the question. Now, is this a full question? Is this the full solution? No, right? Because the question actually asks you to label this. So label this as C. How do I know it's C? Read. Label graph C. Label this graph as C. So please remember to read this. Okay, part D, it is again a giveaway for those who have memorized their content knowledge. State 3 factors affecting the rate of evaporation. Okay, Then after that, it says what, assuming containers still contain water of the same blah blah blah. This one is to make sure, is to help you to frame your argument, because one of the factor on evaporation is the starting temperature. The hotter it is, the easier for it to evaporate. So what they are saying is that temperature should not be a state factor, because it's the same temperature here. So you cannot use temperature as a factor for this evaporation. You cannot state temperature as a factor that affects the rate of evaporation, because they say that the temperature is same, okay, between the two cases. So go and read your textbook, go and find out what are the factors affecting the speed of evaporation. Okay, the rate of evaporation basically means the speed of evaporation for those who are weaker in English. So go and read it up, okay? Go and find out what is it, and if you're not sure, come and approach me. Okay, question 2, as you can see again, it is your wave. Okay, then the first part of the question, water wave is a transverse wave. So they already tell you that water wave is an example of transverse wave. What they mean by a transverse wave? So there are two parts of it. Number one, you have to talk about the particles in the wave. Transverse wave is characterized by how the particle move. It's not by how the wave move. So you have to specify it is the particles in the wave is vibrating perpendicular to the wave motion. So you have to talk about the particles in the wave, how it vibrates, perpendicular, and perpendicular to what? To the wave motion, and you get the full 1 mark. Okay? Do not just talk about, oh, transverse phase perpendicular to wave motion. What is perpendicular? Okay? You have to tell me A perpendicular to something. So in this case, particle perpendicular to wave motion. State the difference between transverse and longitudinal wave in terms of vibration. So you have to talk about vibration. I think this is very, very simple. The vibration of a transverse wave is perpendicular to the wave motion. Vibration in a longitudinal wave is parallel to the wave motion. That's all. Very simple 1 mark. It's a giveaway. Okay, calculation. You have to find the speed. So state the speed of wave formula, V equals to F lambda. Go and look at the question. Okay. They have already given you the frequency of the wave is 8 Hz. So therefore F is 8. But you still do not know what is lambda. Okay, you have to find this. V stands for speed. So in order to find speed, you have to substitute value into these two. So now we want to find lambda. To find lambda, you read this graph, because this is the only other information you're given. So this is displacement distance graph. And from displacement distance graph, one complete wave. So how do you count one complete wave? You can either count from peak to peak, meaning that this one is 5, this one is 9. So wavelength 4. This is one way of counting wavelength. Another way of finding is this is the original point, pass through original point. So one peak, one bottom, this is also one wavelength. Okay, you notice that the value you get will be the same, it's still 4. So once you know that it is 4, now this is very tricky. This is 4. For what? For cm. And if you want to use this formula, it has to be in SI unit. So this guy here must be in meter. This guy here must be in hertz. And what you will get is meter per second. So from the graph, you know that your lambda is 4 cm. How do you know it's cm? Look at this. This is cm. Yeah? So 4 cm, so therefore it is 0.04 meter. Once you have this, put it into your formula, you get meter per second. Cool? Okay. Then you have another part. So you start off with another curve. So this time you are asked to find the period. Okay, to find the period, you can use F equals to 1 over T. T is the period, F is the frequency. Why do I use this formula? Because the question gave you the frequency. So it's pretty simple. This is how you do the mathematics. You make t the subject, so you get equals to 1 over f. It becomes like that. Now please remember that the unit for period is seconds. It is a time, right? Time taken for one complete wave. So it is measured in seconds. Then after that, you are supposed to sketch. Now, just now you are asked to read displacement distance. Displacement distance. Look at the x-axis. Now you are asked to find the displacement time. So go and write it properly first. This is displacement in meter, and this is the time in seconds. Okay, so look at this. Amplitude is 4 cm. 4 cm is 0.04. So you know that it is going to reach 0.04. This is your highest point, and it will have a positive highest point. It will also has a negative highest point. Okay, and you know that the period from from part 1 is 0.5. So what this says is that it will form one complete wave in 0.5 seconds. This is the definition of a period t. So look at this, meaning that you want to form one complete wave in 0.5 seconds. You want to form one complete wave. So to form one complete wave, very easy. From the start, one peak, one bottom. Okay, so draw your thing. Should draw very nice. Okay, for you, I suggest you use pen. You use pencil. Okay, because I have been drawing graph for very long. So complete it, and I'm good artist. So if you don't have the confidence, use pencil. Okay, that's it. That's your displacement time. Okay, it does not really look good. Okay, I should up a bit. Okay, I shouldn't be so perfectionist. I'm making a video. Okay, yeah, I cannot waste if not it will be like a few gigabytes. Okay, we have finished the paper. Oh my god, just take 1 hour. So please revise. I'm going to upload the 2013 paper to my blog. So if you don't have enough things to study, you can refer to that as well. Okay, good luck for your mid-year exam. I really hope you all do well and make me proud. Okay, make yourself proud. Okay, do your best. Good luck.